Hello everyone, hope you all are doing well. So in this video we'll discuss the third problem of Leetcode Weekly Contest 349. It's a medium level problem. I've already created a video on this problem, but after the contest they have changed the problem statement. Okay, in the contest, during the contest also the problem statement was very confusing. Rather, I would say the problem statement and the description and the examples were contradictory. However, because since you basically are forming a cycle in this solution, the answer that we were getting was correct. So now what I have done, since the description is updated, let's solve this problem again. And in that case I was using a sliding window approach. This solution is much easier to understand and much shorter as well. So let's start. Let's start from the beginning. So the problem name is collecting chocolates. Problem statement says that you are given a zero indexed integer array nums of size n representing the cost of collecting different chocolates. Okay, the cost of collecting the chocolate at index I is nums of I. Okay, remember it's the index that is playing a very important role, right? Each chocolate is of a different type, and initially the chocolate at index I is of ith type. Okay, in one operation you can do following with an incurred cost of x. Simultaneously change the chocolate of ith type to I plus 1 mod nth type for all the chocolates. Why is this mod n? Because for the last element what will happen, this will be changed to this. Getting it? This chocolate will change to this type. That is why it is written mod n, because it is forming a cycle. Return the minimum cost to collect chocolates of all types, given that you can perform as many operations as you like. Okay, this is what the problem is asking us to do. In one operation you can do this. Let's start. So 21 and 5, this is my array. Initially this, suppose this is chocolate 0, rather type 0, type 1, type 2. Okay, now at this index, whatever is the type of chocolate, if I buy it, I have to pay 1 unit of cost. Okay, so let's buy, since this is the minimum cost, right? Let's buy type 1 chocolate. Okay, I buy type 1 chocolate at cost 1. Okay, that is done. Now I perform this operation. Which operation? That's mentioned here. To perform this operation, what I have to do? I have to pay a cost. What is that cost? Till now I have paid 1 unit of cost. I'll pay 5 units more. Okay, and then what will happen? The ith type will change to I plus 1th type, meanings a left shift. Okay, so that means initially this was 0th type, it will change to type 1 like this. This was initially type 1, this will change to type 2 like this. Okay, and this was initially type 2, it will change to type 0 like this. Okay, a left shift is happening. Okay, by 1 unit of place. Okay, now again, now at this index, if whatever chocolate I buy at this index, the cost is 1. So now I have type 2 chocolate present here. So I'll buy 2 as well. I have bought 1, I'll buy 2 as well. Okay, I'll pay a cost 1. Total cost is this. Okay, done. Let's do this operation once more. So I'll pay a cost 5 for that, and I'll basically shift it. So 2 will come here because this chocolate will change into this type. So this is 2. This chocolate will change into this type, this, and 1. Okay, so I bought type 1, I bought type 2, type 0 is remaining. Now I can buy type 0 with a cost of this plus 1. So total cost here is 13. So that means by paying 13, I can buy all the 3 chocolates. Now I have to return the minimum cost. So if you perform any other operation, or you take any other order of the elements, you will see that whatever cost you get is more than 13. Okay, so that is what we want to do here. Let's take the second example. So in the second example, I have 1, 2, and 3. This is type 0, type 1, type 2. Now this is the minimum cost. I'll buy chocolate of type 0 by paying a cost of 1. Now suppose if I perform this operation, I'll have to pay a cost of 4. So 1 plus 4. So this guy will become type 1, this type 2, this type 0. Again, I bought this type of chocolate. Let's buy chocolate number 1 of type 1. So I'll have to pay a cost of 1. Getting it? So you also bought this. Now if you are left with, you have bought 0, you have bought 1, you are left with 2. Okay, what are the options? If you do not perform this operation, you'll have to pay a cost of 2. If you perform this operation, you'll have to pay first a cost of 4 and then again buy it at cost 1. Okay, what I mean to say, the total cost will be greater than 6. However, if you do not perform this operation even a single time and rather buy the chocolates as it is, what will happen? The total cost will be 1 plus 2 plus 3, that is 6. Okay, since we have to return the minimum cost, We'll just see what are the options. One option is you do not perform any operation. Second option is you start performing the operations, right? Now it also depends how many operations do you perform, right? So let's see how many maximum number of operations can I perform. Okay, let me just erase it. Let's see. Okay, so just see, suppose I'm given an array like this. This is type 0, type 1, type 2, type 3. Okay, if you perform one operation, what happens? It shifts on the left hand side. This becomes 1, 2, 3, 0. This is one operation. Let's do one more time. 2, 3, 0, 1. One more time. 3, 0, 1, 2. Let's do it one more time. 0, 1, 2, 3. Look, this is the original array. This is the original array. That means the number of elements I have, okay, I can perform at max those many operations, right? Because at the first position, how many possibilities do I have? Either I can have the first element, second element, third element, or the nth element, right? So that means the maximum number of rotations that you can perform is just n, the number of elements, because the moment you perform more operations, actually you're repeating the cycles, okay? So why to pay extra cost to go to the same configuration, right? So this is one thing. Now let's see, how do we pick up a cost, okay? How do we pick up a cost? So let's come to that point. So suppose these are some of the elements I have, okay? Some chocolates. This is type 0, type 1, type 2, type 3, type 4, type 5, and some corresponding cost, okay? Now, if I want to calculate the cost at which I'll buy this chocolate, okay? So what are the options I have, right? What are the options I have? This is type 1, okay? This is type 1. So if I do not perform any operation, then to buy chocolate of one type, what I'll do, I'll consider this cost, okay? What is the other option? If I perform this operation one time, so this will move here. That means this will become, this chocolate will become of type 1, this will become type 2, 3, 4, 5, and this will become 0. Okay, getting it? That means either I can buy without performing any operation, either I can buy chocolate number 1 using this cost, or if I perform this operation one time, I can buy this chocolate at this cost, okay, at this cost. Remember, the cost is not changing, rather the chocolate type is changing, okay? Suppose I perform one more operation, so what will happen? This will shift here. So 2, 3, 4, 5, 0, 1. So if I perform this operation one more time, I have one more option. I can buy this chocolate at this price, okay? Remember, I'm talking about chocolate of type 1. So the first one was either you can buy at this price, or after doing operation you can buy at this price, okay? After doing one more operation you can buy at this price, okay? Because one has come here. Again perform an operation 3, 4, 5, 0, 1, 2. Now what is the other option? You can buy, if you perform this operation one more, remember this was one shift, 2 times, 3 times, 4 times, 5 times, 6 times. These many times you can perform the operation. So if you perform the operation 3 times, now you can buy this chocolate here. Again perform this operation 4, 5, 0, 1, 2, 3. Now if you perform this operation the 5th time, you also have this option, right? You can buy at this price as well. Remember, these are the options you are getting. So till now you have got 1, 2, 3, 4, 5 options. So obviously out of these 5 options, you'll choose the minimum one, right? You'll choose the minimum one, right? Let's again do one more operation. So in that case, 1 will come here and I'll have this option as well. So what I mean to say, the number of operations you perform, the more number of options you have, okay? Initially I was standing here, type 1 was here. If I perform operation, basically I can buy the chocolates at a price which is minimum of these two, okay? If I perform this operation one more time, that means I can include this element as well, okay? So I can buy the chocolate at minimum price of this, this, and this. If I perform this operation one more time, I can buy the chocolate at minimum price of this, 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 and this, okay? That is the main intuition. So what I'll do, since the constraints are very, very low, I will perform, at max I can have 1000 elements. So I'll perform this operation 1000 times, okay? 1000 into 1000 will be my time complexity, okay? So to facilitate it, what I'll do, I'll just take some extra space. Again, I have taken extra space, you can avoid it, but just to make the code a little bit, clean, I have done it. So taking the space and basically optimizing it. So let's see how the code works, okay? And it will become crystal clear. You initialize your answer with a maximum value. These are the number of elements, and this is the minimum cost. Okay, why I have taken the minimum cost? Because as I explained you, suppose this was my array, right? And I have suppose 4 options for this element. Suppose 1 2 3 4, I have 4 options. So what I'll do, minimum cost of at a particular index will basically store that what is the minimum cost to buy that type of chocolate. Okay, that means min cost of 0 will store what is the min cost to buy 0th type of chocolate. Okay, how I'll compute it, I'll just show it. Okay, now you fill all the values in it with max values. Okay, now let's start processing. Okay, I is equals to 0, I less than n, because how many times can I perform this operation? Either 0 times, 1 time, 2 time, or at max n minus 1 times. Okay, n minus 1 times. The moment you perform those operations n times, what happens? Again you form a cycle. Getting it? So that is why. Now if I the number of times I'm performing this operation, I'll have to pay a cost, right? What is that cost? X into I. So if you do not perform any operation, this cost will be 0. Okay, that's it. Now comes the main logic. Main logic is what is the minimum cost to buy a particular type of chocolate. Let's traverse your array. Okay, so min cost of j, because this is index j, min cost of j equals to math.min of whatever is the minimum cost till now and nums of I minus j plus n mod n. What do I mean by this? If this is my array, okay, I am standing here and I am performing this operation I times right now. Suppose that I equals to 1. So I need to include this element as well. So I am standing at ith index. J is equal, right? I am standing here. Okay, I and j you can change it. I can make it j minus I as well, right? Because this will be mod and you take it, right? I'm standing here. I go how many steps back? The number of operations I'm performing. Okay, the number of operations I'm performing. So you go here and this value can become negative, right? This value can become negative, and that is why I have taken plus n here, right? That is why I have taken plus 1 here. So it totally depends how many operations you are performing, and based on that what are the values you are including, and that is why this value will keep on updating. Getting it? Here I have written I minus j. Actually you can write j minus I, because I want to calculate for jth index and the number of operations I am performing is I. So j minus I, both will work. So here I have written I minus j. You know, we are familiar with using I and j, right? So I comes first, so that is why I have written it. But yeah, you can use anything. So these are the indices. You are standing at jth index. If you perform this operation 1 time, so you include this element as well. Now as soon as you increase the number of operations, what you will do, you will also include this element. So that is why in that case what will happen? J minus 2. So j minus 2, you will come here and you will do plus n, because this value has become negative. Getting it? So that is why I have taken plus n mod n. Okay, so that this cycle is taken care of. Then after you perform this operation one more time, for this index you will include this value as well. So that is what I am doing. And finally what you do, sum plus equals to min cost of j. Okay, so that means at the ith operation, first you calculate what is the cost of buying jth type of chocolate, minimum cost of buying jth type of chocolate, and then add it. And at every step what you do, answer equals to math.min of answer and sum. Okay, then finally return your answer. Okay, this is sort of also on the same lines on which I wrote the first solution. That was, I would say, something that I wrote during the contest, and that was a little bit long solution, introducing a couple of concepts. This one is a much easier one, and also I would say the problem statement was very confusing that time, contradictory to what they gave in the example. Now it is okay, right? Now they have changed the example as well and the description as well, so now it's much better, right? So yeah, I hope you learned something new from this video. Do support it by giving a thumbs up. Do subscribe to the channel. Also, if you want to learn a different way to solve this problem, you can watch that video as well. I have attached that video in the same playlist of Leetcode Weekly Contest 349. You can just watch it and you'll get one more way to solve this problem, right? Though the problem statement is a little bit difficult to understand, but again you get to solve you get to know a different method to solve similar type of problem, right? So yeah, take care and I'll see you in the next video. Bye bye.